If you're building anything with AI, you know the struggle. That painful pause, that lag between asking a question and getting an answer, that's latency, and it's one of the biggest hurdles we face. Well, today we're going to pull back the curtain on two really powerful techniques designed to absolutely crush that lag and make these huge models feel, well, almost instant.
You gotta love this quote, right? It perfectly captures the idea that huge performance gains aren't always about some massive breakthrough. Sometimes they're just clever shortcuts, hiding in plain sight. And today, we're gonna go find that free speed.
So the big question is, where do we even start looking? Well, the answer is actually inside the model's own process. Just think about how these things work. They generate text one little piece at a time, one token at a time. The inefficiency we're going to target is all the repetitive, unnecessary work the model does between generating each and every one of those tokens. Okay, our first technique is called the KV cache. And honestly, the best way to think about it is like giving the model a short-term memory. Instead of having to reread an entire conversation from the very beginning every single time it wants to add a new word, it can just, remember what's already been said. So here's the nitty-gritty. To understand context, a model has to do these calculations called attention keys and values for every single word. Think of them as little notes the model makes about which words are most important to the conversation. Now, without caching, it has to recalculate those notes for the entire history every single time it adds a new word. It's crazy inefficient. KV caching is the simple but brilliant idea of just saying, hey, why are we redoing all that work? Let's just store those notes and reuse them. And the process is just pure common sense when you see it laid out. So, picture this. You say, hello, how are you? The model generates all those attention keys and values for that phrase. Then, step 2, it pops them into the cache. Now, for the crucial part, when it's about to add the next word, maybe today, it doesn't need to reanalyze hello, how are you at all. It just pulls that context right from the cache and focuses only on what's new. That's the shortcut. That's where the speed comes from. And you can probably already see where this becomes a total game changer, right? Think about a long chatbot conversation or summarizing a massive document. The context is huge, but it stays pretty much the same. By not having to reprocess that entire history for every new word, the model gets this massive speed boost right when you need it the most. All right, so that brings us to our second technique, and this one is really cool. It's called speculative decoding. I love this analogy for it. Imagine a team up between a really fast, eager assistant who just guesses what to say next and a super wise, careful verifier who checks all their work. So here's the brilliant trade-off. Instead of making the big, slow, super powerful model generate words one by one, which takes forever, we use a much smaller, faster draft model to just sketch out a few guesses, maybe 5 or 6 words into the future. Then, we take that entire draft and hand it over to the big model, which can check the whole chunk of text in one single go. It's kind of like writing a whole sentence and getting your editor to approve it all at once, instead of getting approval for every single word. And this chart just lays it all out perfectly. The draft model, it's all about speed. The quality just needs to be good enough. The target model, on the other hand, is the opposite. It's slow, but its output is flawless. By having one guess and the other verify, you get the speed of the small model with the quality of the big one. It's a seriously clever partnership. The whole workflow is just beautiful. First, the speedy little draft model just spits out a chunk of text. Second, the big model looks over that whole chunk in a single forward pass, which, by the way, is way faster than generating each token itself. And third, every token the big model agrees with is accepted. Boom! You've just jumped ahead in the conversation. But of course, as they say, there's no such thing as a free lunch, even when we're talking about free speed. So for anyone out there actually looking to implement these techniques, it is absolutely crucial to understand the potential pitfalls just as much as the benefits. So there are really two main things you got to watch out for. With KV caching, you have this risk of cache invalidation. Imagine you're talking about Apple the company for a while, and then you suddenly switch to talking about Apple the fruit. The model's cached memory might get a little confused. And with speculative decoding, the risk is something called quality drift. If that speedy draft model has a tiny stylistic quirk, over thousands and thousands of words, it could slowly nudge the final output to sound a little less like the high-quality target model you want. So with those trade-offs in mind, what's the actual game plan here? How do you take these ideas and apply them safely and effectively in the real world? Okay, let's build your performance playbook. The key is to be really systematic about it. First, always benchmark your performance.
You have to prove you're actually getting that speed boost you're looking for, right? Second, you have to constantly check your output quality to catch any early signs of that quality drift we were just talking about. And finally, keep a close eye on your memory usage. That KV cache is amazing, but it can get really big and actually become its own problem if you let it run wild.
So, by combining smart techniques like KV caching and speculative decoding, we can build AI experiences that aren't just powerful, but are also incredibly fast and responsive. We've found the free speed. So the only question left for you is, what amazing things are you going to build with it?